Hi guys, welcome back. In this video, we're going to understand machine learning. Nowadays, almost everyone has heard the word artificial intelligence. Some people even know terms like machine learning, deep learning, neural networks, large language models, and generative AI. But here's something I noticed when I started learning AI. Most videos explain the relationship between artificial intelligence, machine learning, and deep learning. They tell us that machine learning is a part of artificial intelligence and deep learning is a part of machine learning. But after watching those videos, I still had one question. What do these terms actually mean? What exactly is machine learning? Why was it invented? And how does it actually work? I couldn't find many videos that answered these questions in a simple way. So I decided to create this series. In this series, we won't be learning programming or mathematics. Instead, we'll understand the ideas behind AI in a simple and intuitive way. We'll break AI into small topics and understand each one step by step. And today's topic is machine learning. Before understanding the definition, let's look around us. Every day, you use machine learning without even realizing it. When YouTube recommends videos, when Netflix suggests movies, when Google predicts your search, when Gmail moves spam emails into the spam folder, and when your phone unlocks using your face, machine learning is working behind all of these. But how does a computer learn to do these things? Let's first understand how we normally program computers. Suppose we want to build a program that tells whether a number is even or odd. We simply write the rule: if the number is divisible by 2, then it is even, otherwise it is odd. Here we are explicitly telling the computer what to do in every situation. This is called traditional programming. But not every problem is that simple. Imagine you want a computer to recognize whether a picture contains a cat or a dog. Can we write thousands of rules like, if the ears are this shape, if the tail is this long, or if the nose looks like this? Practically, that's almost impossible. Instead of writing all those rules ourselves, what if we simply showed the computer thousands of cat and dog images? The computer could study those examples, find patterns, and learn the difference by itself. That's exactly what machine learning does. Instead of writing every rule manually, we provide data. The computer analyzes that data, discovers patterns using mathematics, and then makes predictions or decisions on new data. That's why it's called machine learning. Now let's understand how machine learning began. The idea of making machines intelligent is not new. Back in 1950, a British mathematician named Alan Turing asked a fascinating question. Can machines think? To explore this idea, he proposed an experiment called the Turing Test. The idea was simple. If a person talks to both another human and a machine through text and cannot reliably tell which one is a machine, then the machine can be considered to have shown intelligent behavior. A few years later, in 1959, computer scientist Arthur Samuel developed one of the first machine learning programs. It played the game of checkers. Instead of becoming better because someone continuously updated its code, it improved by playing many games and learning from experience. This became one of the earliest demonstrations that computers could actually learn. But here's another interesting question. If people had this idea more than 70 years ago, why has machine learning become so popular only in recent years? The answer is simple. Back then, computers were extremely slow. Memory and storage were very expensive. There wasn't enough digital data to train models, and powerful processors like modern GPS didn't exist. Today, everything has changed. We have billions of smartphones generating data. We have powerful computers. We have cloud computing. We have GPS that can perform millions of calculations every second. That's why machine learning has advanced so rapidly in the last decade. Now let's briefly understand the three major types of machine learning. The first type is supervised learning. Imagine you're teaching a child different fruits. You show an apple and say, this is an apple. Then you show a banana and say, this is a banana. Over time, the child learns the difference. Later, when you show a completely new apple, the child can still recognize it. This is similar to supervised learning. We train the computer using data that already has the correct answers. The computer studies the relationship between the input and the output, and later predicts the output for new data. For example, if we provide the marks a student scored from classes 1 to 9, the model can estimate how the student might perform in class 10. The second type is unsupervised learning. Imagine placing a box full of colored balls in front of a child. This time, you don't tell the child anything. You simply ask, can you organize these? The child naturally groups all the red balls together, the blue balls together, and the green balls together. Nobody taught the child the correct groups. The child discovered the pattern. Machine learning models can do something similar. In unsupervised learning, we don't provide the correct answers. The computer analyzes the data and finds hidden patterns or groups on its own. The third type is reinforcement learning. Imagine teaching a child to ride a bicycle. At first, the child falls many times, but every successful attempt builds confidence. Gradually, the child learns what works and what doesn't. Machine learning can also learn this way. In reinforcement learning, the computer learns through trial and error. Correct actions receive positive rewards, while incorrect actions receive negative feedback. Over time, it learns to choose better actions to maximize its rewards. This type of learning is commonly used in robotics, self-driving cars, and game-playing AI. So that's the basic idea behind machine learning. In this video, we didn't dive into algorithms or programming because understanding the concept is much more important before learning the technical details. In the next video, we'll understand neural networks and see how they became the foundation of deep learning. If you found this video helpful, don't forget to like the video and subscribe to the channel. Thanks for watching, and I'll see you in the next video.